Okay, for this next unit, we're going to take a look at sequences and series, and we're going to start with arithmetic sequences. So the first thing we're going to do is look for the patterns in these sequences. In the first case, we can see that every single time the number is going up by 5, so the next numbers would be 18, 23, and 28. In the second set, they're going down by 3 every single time. So the next numbers would be negative 17, negative 20, and negative 23. In this third set, they're being multiplied by 3 every single time. So I'm going to wind up with 81, then 243, then finally 729. In the fourth set, they're being multiplied again, but this time they're being multiplied by negative 2. And I'm going to get positive 16, negative 32, and positive 64. For 5, it's a little bit more complicated, but if you look at the pattern, going from A to C, we skipped 1 letter. C to F, we skipped 2 letters. F to J, we skipped 3 letters. So then we would skip 4 letters in the alphabet and go to O. And then we'd skip 5 letters and go to U. Number 6 is an example of what's called the Fibonacci sequence. All the numbers are created by adding the 2 previous numbers together. So if I took 2 and 3, I'm going to get 5, and 3 and 5, I'm going to get 8. So 5 and 8 would give me 13. 8 and 13 is 21, and 21 and 13 is going to be 34. For example 7, we're missing 2 numbers in order to turn this into a sequence. We're going to assume that we're just adding the same amount every single time. And I can say, well, if I added the numbers 19 and 27, then the numbers would be increasing by 8 every single time. And for example, 8 is just multiplying again. In this case, I'm just multiplying every number by 3. So the next number would be negative 135, then negative 405. A sequence is an ordered list of objects. Each number in the sequence is called the term. The subscript m represents the position of the term. So if I look at example 4 here, then this would be term 1, 2, 3, 4, 5, 6. The general term Tn represents any term in the sequence, which means that this would be the value of term 1, term 2, term 3, and if I went on for a while, I could just call it term n, where it can represent any value that occurs in the sequence. So, if I'm looking at example 1, it says, write the first 5 terms in a sequence defined by Tn, or the term value, is equal to negative 2 times the position of the term minus 5. Well, if I'm doing the first 5 numbers, the first one would be negative 2, and the position of this is, it is term 1 times 5. Then I would go to negative 2, and it's term 2 minus 5. Negative 2 and term 3 minus 5. Negative 2 and term 4 minus 5. And finally, negative 2 and term 5 minus 5. Negative 2 times 1 minus 5 is going to give me negative 7. Then I'd go to negative 9, negative 11, negative 13, and negative 15. In this chapter, we're only going to be taking a look at 2 types of sequences: arithmetic, which we're currently doing, and geometric, which is going to be our next lesson. In an arithmetic sequence, the difference between consecutive terms is constant, which means they change by the same amount for every single term. Just like in example 1, they changed by negative 2 every single time. The constant value is called the common difference, which we represent with d in our formulas. So to solve what the value is, it's going to be the term value is equal to the first term plus the term number minus 1 multiplied by that common difference. The common difference is going to be the difference between two consecutive terms, so I could always say that's going to be the difference between one term and the term that came exactly before it. Given the first 5 terms of a sequence, what's the value of the first term? Well, T1 is going to equal 4. What is the common difference here? Well, the difference I could get from either the second term minus the first term, which is going to be the same as the third term minus the second term, which is still just going to give me 3. What are the next 3 terms in the sequence? Well, start at 16, and I'm just going to keep adding 3, 19, 22, and 25. Is a sequence finite, where it has a clear ending point, or infinite, where it goes on forever? Well, this ... means that the sequence is just going to keep continuing over and over and over again. This is going to be infinite. So there's a little typo here. It should say, what is the value of term 7, not 71? And the value of term 7 is, well, this was term 1, 2, 3, 4, 5, and we continue it down here, 6, 7, 8, and there's the value of term 7. We've already solved it. Term 7 is equal to 22. If I want to solve for the general term, then I'm going to say that Tn, or the general term, is going to equal 4 plus n minus 1 times a common difference of 3. If I'm using that general term to find the value of term 152, then I would say that term 152 is equal to 4 plus 152 minus 1 times 3. Or term 152 is going to equal 457. If I'm graphing out this sequence, well, my y values, or what's on the left-hand side of my equation, is going to be my Tn's. On the right-hand side of the equation, what I'm solving is for the term number. So the value of the term is going to be based on the number. We always skip 0, and we can go straight to term 1 is going to be 4. Then term 2 was 7, 3 was 10, and so on and so forth. And we can see that this arithmetic sequence forms a linear relation because it's changing by a constant amount. Each time that my n goes up by 1, my y is going to go up by, or my Tn is going to go up by a set amount because of that common difference. Given the sequence -3, -10, -17, and -24, is this arithmetic? Well, if I look at how much it's changing by every single time, then it's arithmetic if it's changing by a set amount. This went down by 7, down by 7, down by 7, which means that, yes, it is going to be arithmetic. For the common difference, if I'm showing how to get it, the difference would be -10 minus -3, or what we already said, -7. What is the value of term 20? Well, term 20 is going to equal the first term, -3, plus 20 minus 1 times -7. The 20th term is going to be -136. And when it says which term in the sequence has a value of negative 339. Well, this is telling us what our Tn is, and now we're going to be solving for n in our equation. So we're going to say that negative 339 is equal to negative 3 plus n minus 1 times negative 7. I'm going to start by subtracting negative 3 or adding 3 to both sides. Negative 336 is equal to n minus 1 minus 7. I'm going to divide both sides by negative 7 and get 48 is equal to n minus 1. And then I'm going to add 1 to both sides. 49 is equal to n. This is the value of the 49th number in this sequence.